I'm going to give a quick introduction. This is Chen. He's dialing in from the South Bay. I'm
Folks.
here in San Francisco. So Chen is he's many things. He's a leader in the, let's say, quantitative sciences. His current role is head of ML at FAIR. He and I got to know each other at Stanford in 2008,
Yeah,
I think,
2008 and 9 and 10-ish.
and 10. Yeah,
Many
so
years ago. Yeah, more
many,
than
many years ago, Chen was a grade ahead or a year ahead in the research program I was in management science and engineering. Chen went on to finish the PhD. I I took the exit route after
I
a
was
few
not
years.
entrepreneurial enough, so I actually finished the PhD. Yes.
I suppose is one way to put it. And then went to Google.
Yeah.
Um, and then after Google was Uber,
Yes. Yes.
and then ultimately running ML for Uber Eats.
Data science.
Is data
Yes.
science. Yeah, yeah. So this is a great, actually, okay, interesting. So I said
Yeah.
ML, you said data science,
No, it's a
and
both. I mean,
yeah,
this
yeah.
fuzzy. These are the lines are fuzzy, anyways. So.
Lines are fuzzy anyway. So this is a good terminology, right? Is an interesting thing. So we have AI, data science, ML. I think a lot of people talk about large language models, LLMs now. Like, how in your head, what's the like graph relationship
The Venn
between?
diagram of all the different
Yeah,
terminologies. Um, I'm not sure there is a one official way to define some of these concepts, like data science is today still, if you ask 100 different people, they may give you like not 100 but 90 different answers.
right, for
Let's
sure.
maybe leave data
Just
science.
like doctors, by the way. You ask
Yeah,
100
yeah,
doctors, yeah,
yeah,
you get 90
yeah.
different answers.
Okay. So we can maybe leave data science aside. Maybe let's clarify the few other things like AI, ML, large language model.
Yeah.
What are the relationship between these things? And today, because of the frenzy around AI, we're kind of using AI as a catch-all term, right, to refer to anything fancy, anything kind of artificial intelligence related or algorithm related.
Yeah.
But like,
Yeah.
if you go back to what the original definition is, I think AI is actually the broadest concept,
Hmm.
among these a few words we were
It
talking
sort
about.
of contains all the others.
It's a container, right? So like
Yeah. You
artificial
know what's,
intelligence.
I'm thinking, we didn't even include the term statistics in here.
No, yeah, we didn't, right? Yeah, that will introduce even more kind of a nuanced
Yeah.
complexity. So I think like AI, like it's a very old definition, like anything kind of a either heuristics, right, or algorithms
Hmm.
that can make decisions independent of a human, right?
Hmm.
Uh,
So this concept of autonomy is important.
right, I think so. I think like in fact, if you remember in the old days, even methodologies such as a pattern recognition
Hmm.
or expert system where you predefine some rules to let the system make decisions autonomously, right? So those are all referred to as artificial intelligent systems,
So
right?
even so that kind of world, you have rules-based system, so-called expert system, is
Yeah,
all just a sequence of propositional logic. It's a collection of proposition
right.
after proposition after proposition. And
Yeah, it's really
if it
dumb.
can if it can do things, if it can make decisions independently or run independently, then there
Yes,
was a time when that was sort of the state of the art
yes.
of
In the
AI.
broad concept of AI, I think that is actually a type of AI systems. And then later on, I think maybe in the more recent a couple of decades, then you have this machine learning term, right, coming up. I think it's actually a subdomain within AI
Mhm.
where you have this uh, kind of a machine-driven like algorithm that are learning patterns and relationship from a large data set,
Yep.
and then establish connections between the features and the target variables, and then using
Mhm.
the relationship to later on um, help people make decisions, make predictions.
Yep.
I
Yep.
think that is machine learning, right? So, for
Yep.
example, classification methodologies or regression methodologies, I think those are all, part of the machine learning domain. Okay, it's actually a subset of the broader AI kind of a
Yeah. Yep.
circle field. And then maybe in the more recent 10 years, right? And then yet another subset coming within the machine learning area is deep learning.
Yep.
This is a particular type of ML methodology based upon neural networks. And then people started building this kind of a multi-layer perceptron, multi-layer neural networks, essentially mimicking how human brain might be working. And it's a more complex machine learning model that can help better capture nonlinear relationship between let's say features and then target variables.
Yep.
And then with the enablement of technology, especially infrastructure, kind of a computation, kind of improvements, we can now kind of run this very deep neural network that has a great prediction power. Okay, so that's deep learning, which is yet another subset of a machine learning. Okay.
So yeah, AI, broad concept, kind of computers autonomously making decisions or coming to conclusions. If that is involving, let's say, learning or estimation from data, we apply the term machine learning as a subset. And then if we sort of, there's classification and regression techniques which try to predict categorical variables or continuous variables. Like if you have a
Like
patient in
simple linear regression, right?
simple linear regression,
That's
it's
a
machine
machine
learning
learning model. That is a
for
machine
sure.
learning. Yes.
Without
Yeah.
and so I think that's probably the implication is an important point to make. Like when we talk about AI is the broadest concept. Like AI has tremendous utility even in those techniques. These trying to classify something. This patient, let's say in the ICU, do they have sepsis or not?
Right.
You know, we're trying to classify them as one that requires intervention to either prevent sepsis or to treat it as early as possible, or as someone that doesn't need that intervention, right? And
Oh,
so that's within the scope of AI, within machine learning classification problem. And then regression for predicting continuous variables, things like probabilities, right? That's where things get a little fuzzy, right? Because but also things like how might weight be trending for this patient who's on obesity medication, or um, how might some other lab value that we care about be trending. And then within that, if we have lots of data, and you said actually the infrastructure piece here, you mentioned the infrastructure, which I think is important. Like why now? Why is there this like explosion now? There's AI, machine learning, classification and regression, there's deep learning and neural networks, and the infrastructure that's sort of made it possible to run those computations.
totally. Yeah.
And
Especially
like
for
so is it that, I guess the specific question would be like the infrastructure piece is you kind of need the horsepower to be able to do it. And then economically speaking. But then the other part is just the techniques. Are there any new techniques or new math, new statistics that's theoretical advancements in nature versus the practical or even like mechanical advancements or material science advancements that enable GPUs, to do what they do?
I think definitely there are scientific advancement, methodology advancement in the past couple of decades propelling this recent frenzy, right? This is what about outbreak of large language models. The backpropagation, right, which was invented decades ago by Jeff Hinton and his students. I think that was one major milestone, which kind of laid the foundation for efficiently train the neural networks, right? So theoretically, that was the big unlock to allow us to be able to actually tune the parameters in a deep neural network. Okay, so that breakthrough, the invention of backpropagation, make that all possible theoretically. But then for many years, there isn't enough computation capability available.
To go deep.
Go deep, to actually go that deep, to actually do that computation in a reasonable amount of time. Okay, so therefore, even though that backpropagation methodology was invented decades ago, it is not until the recent 8 or 9 years that it actually become a pragmatic methodology to be applied
Yep.
in the actual industry settings to
Yeah.
solve real problems. So that's one. And then we all know that in 2017,
Attention is all you need.
yeah, there is then this another breakthrough coming from Google. A few researchers at Google that invented this new transformer architecture. I'm not expert on that. Okay, so but just think that as another big breakthrough in the architecture of the neural network. Okay, which can essentially allow us to train as a huge network in the parallelized and decentralized manner. Okay,
They're really efficient, like fast training.
yes, which
Yeah.
so make it a way faster to train this a huge neural networks in a distributed parallel manner so that we can concurrently simultaneously train many subnetworks and then efficiently converge, right, to the
Yeah.
optimal network structure as well as the parameter value. Okay, so this is a huge unlock, another huge unlock. Essentially, that's the foundation for this recent couple of years, kind of this huge innovation around LLM and the large language model is all based upon this transformer architecture, which was invented
Yep.
at Google in 2017. And I think what is also happening in the past couple of decades is the accumulation of data. Okay, I think
Yeah.
you can argue that maybe like 20, 30 years ago, before this whole internet and especially mobile internet era, there was limited data out there, especially limited data about consumer behavior, right? But then in
Yeah.
the recent couple of decades, because of the prevalence of internet connected devices, mobile devices, and also social networks, e-commerce site, social media, there's a
So
huge
much happening online.
yeah, so
Yeah.
much happening online. So, and all of these activities and behaviors are being recorded, right?
Yeah.
And then that
Yeah.
is another very important,
Like this one right now.
exactly. So
Yeah.
this is another important ingredient of the formula, right? So because you need
Yeah.
algorithm, you need data, and then you need a computational power. All three have to come together
So
to
I want
in
to replay that the three ingredients here. You need the data, you need the algorithm, and you need the compute.
yeah,
And it's
exactly.
like without if you're missing one, it doesn't you can't go. The stool falls over. Like you
Yes.
got to have all three.
Yeah, so essentially we can say that in the past several years, we really see maybe past, let's say, since mid 2010s. Okay, so we really see the three things all coming together. Okay, and then it creates this environment, this condition for AI, or but I guess for deep learning, and then now more
Yeah.
recently, the large language model, right?
Yeah.
Foundation model to really take off. Okay. I think that's why we've seen this this quick, very fast evolution development.
It feels like an explosion, right?
Feels like explosion. I think it's a combination of many decades of
Yeah.
advancement
Yeah.
across all different areas we talk about, right? So methodology improvement, infrastructure improvement, and also accumulation of data of
Yeah.
human behavior, of industry, whatever activities.
Yep.
It's all coming together in the recent few years, and it created this explosion. Yeah.
Do you have a personal story of like I have a version of one where I for the first time kind of was like, whoa, this is different.
Totally. Yeah.
Do you
Yeah.
remember? Can you tell us what's the
Well, I think it's similar to many people. It's the first time I used ChatGPT back in
what was
what
the first prompt? What should I
December.
have for dinner?
I think I was asking it to write a poem
Ah, okay.
and based upon certain keywords or maybe some theme.
Yeah.
Now I said it write a Chinese, like in the Chinese old fashioned, like, do you know, like
Traditional.
in traditional Chinese, like
Mhm.
Tang Dynasty, like people used to write this poem following a certain format. It's a very rigid format. Okay.
Okay.
Have to have the tones right, and you have the exact number of characters. Uh,
Okay.
so it's not easy to write one. Okay. And if in a thousand years ago, if you're good at writing those poems, you will become a celebrity.
Okay.
Most the famous people in China 1,000 years ago are all poets. Okay, they're great
Wow.
at
Okay.
poems, and then that's how their name will then be remembered for thousands of years. Okay,
I see.
thousands of years. Anyway, so I just asked ChatGPT to write this poem, and it just did a perfect job. Uh,
Wow.
and later on,
Wow.
asking a bunch of questions, I used ChatGPT as a therapist.
Uh-huh.
Oh,
Yeah.
yeah, I was say, hey, I'm struggling with this, whatever stress or whatever
Yeah.
issue, help me see things in different ways, and then, whatever. So just having this kind of interaction, and I
It's
feel like it's valuable, and it gives me the response and answers that are totally reasonable, like on a human level. Yeah, I feel
yeah,
it's on the same level as me,
very impressive.
Yeah.
Very
So
impressive. The
now, yeah, go ahead.
well, I was gonna say I did also early on experiment with a little poetry.
Yeah,
In part, I think because I maybe we associate that with being very
creative. Uh,
human, right?
yes.
That it's in the domain of the human. There's something
Yeah.
sort of that feels like it shouldn't be the domain of machines, right? It should be human. And but then to see that from a machine changes the perception. But for me, the thing that
Yeah.
really nailed it was more sort of professional in nature. I had this like data set I needed to analyze. It was like not big, but kind of
Yeah.
big enough to be not trivial. It was a million rows or something like that. And I just kind of like gave it to ChatGPT and
Ah,
I asked it to do certain things and produce certain visualizations
boy.
and summarizations and
Yeah.
transformations and it was hitting errors and then it was correcting itself. It was like out of memory error. Okay, I'm gonna try chunking. I'm gonna
Yeah.
chunk it now,
Yeah.
to reduce the memory footprint. And I
Oh,
was standing there, comes back to your original
yeah.
characterization of AI to say like autonomy.
Right.
This idea that like intelligence and independence are actually very linked concepts. And this thing was independently trying things and making a judgment call on where to go next
Yeah.
and then trying it. It actually and it got to the output. It probably took a couple minutes, but I was watching it go. And when I saw that, I was
Yeah.
blown away. And
Yes.
now what I do is it's fascinating. You mentioned how in my personal life I use it to write bedtime stories
Mm-hmm. Yeah. Yeah.
for my
I
boys,
do that too.
3 and
Yes.
7. But what I
Yes.
try and do is I try and work if something like I remember one day my 7 year old had some conflict at school and it was not new. I kind of had the context for it, but so I asked ChatGPT to write a story that had this moral I wanted to communicate to him,
Yeah.
and I wanted that moral in the story,
Yes.
and it produced, and I'm like write a 10-minute story appropriate for a 7 year old that includes this sort of value of forgiveness and this kind of thing, and it
Totally.
was just
Yeah. Did you try the latest GPT-4o?
I have
Uh,
not,
if you
no,
haven't, you absolutely have to give it a try. It is even more magical now. So it has this so like it's seamless kind of a conversational dialogue type of experience, like audio based. Okay, so you like for
yeah,
example, driving, I'll just open the ChatGPT app
start
and
talking.
enable ChatGPT 4o, and you can just start chatting with the app. Okay, and then it speaks to you like a real human. Okay, and my son is in the back seat. We will just talk about things like sci-fi ideas, or I can just say, "Hey,
It
make
feels
story."
like it's sitting in the car with you
Yeah,
having a
it is. Yeah,
conversation.
exactly. Make story now, and then just read it out to Alex. And he now knows things about Alex because he has memory. He remembers what Alex likes, and he
Yeah,
has
yeah.
stories. Yeah, and like last time we were driving on the road, we were talking about, this flower called a hydrangea?
Uh-huh.
Hydrangea.
Uh-huh. Yeah.
So I heard from people that you can change the color of the hydrangeas, okay, by changing the pH value of the soil. So like I was just talking to the ChatGPT 4o and I was want to understand how does that work. So basically having this conversation with ChatGPT 4 about changing color for hydrangea, from pink to blue to purple, and basically tells me why you can change, how do you change, what are the procedure of changing that. And then in the end, he's like, and I was like, can you also write a story now based upon this whole conversation? And he literally just write a story based upon changing color for hydrangea and how a little boy kind of is an interest fascinated about that, and then just starting to play with that in his
Yeah.
grandparents' yard, and
Okay.
kind of doing
Puts the
all.
eggshells over here and the coffee grounds over there, kind of thing.
Totally, yeah,
Yeah.
and in the end, it also weaved in some kind of a philosophical, inspiring, whatever moral of the story, and then it's added
Yeah.
to the
Yeah.
height, and all of that was done while I was driving, and my son was sitting in the back seat. It was just such a
It's
unimaginable.
unimaginable. Yeah.
Yes, like
So with how are you on time? It's
I
3:45. Can we
can,
do another
I can,
5 minutes? Okay.
yeah, I
The
don't actually. So yeah.
when you think about the application to medicine,
Hmm.
right? And or healthcare at large, which is there's a very long value chain in
Right.
healthcare, right? There's everything from, if we go way, way up, there's companies like Benchling that are sort of systems of record and systems of work for drug discovery and discovering and developing treatments, or new diagnostics. Like, can we detect cancer from blood tests? Um, there's small molecule, large molecule. There's gene therapies, everything in terms of creating new tools for practicing clinicians.
Hmm.
I would consider that very kind of upstream. And then
Yeah.
there's like the practice of medicine where AI scribes have been around forever. Human scribes, dictation has been around forever. Where, if you're my physician, I'm your patient, whether it's telehealth like this over Zoom or in person, our conversation might be transcribed and turned into a note for accurate records. And then there's some sort of metadata or ontologies, terminology systems that the conversation might get mapped to, right? So concepts that we cover might get mapped to specific semantic
Hmm.
uh, concepts that have a sort of a computational meaning. Um, but anyway, these AI scribes are there's like, I don't know, 100 of these companies that are taking LLMs, which are used both in the transcription of voice data,
Mhm.
audio to text, right? The LLMs are being used there to take the voice data and turn it into text. And then they're also being used to take the text and turn it into a doctor's note, which
Mhm.
is like another transformation, another type of reduction
Yeah.
or mapping. And that's sort of a very practical, some you might even say administrative, but in that
Mhm.
is sort of also like decision support. For example, what is the right sort of monitoring cadence for patients with chronic disease? And is someone due for a new lab test result, or
Mhm.
is someone
Yeah.
uh, does it look like someone might need to have their medication dosing adjusted, that kind of thing.
Yeah.
And then so I put that like the middle value stream is like making care delivery. We talk about upstream is like the drug
Mhm.
and diagnostics
Yeah.
development, like life sciences. In the
Yeah.
middle is sort of care delivery, making the
Yeah.
experience and the quality of care with patients better. And then
Yeah.
there's all the administrative and operational stuff. Can we make it easier to schedule an appointment?
Yeah.
Right? Can we classic sort of like what we were doing in operations research, where can we what's the right sort of scheduling gymnastics to get you to
Oh.
a specialist in the right way? What's the right, and then all the billing, insurance nightmares, prior authorization, that kind of stuff.
Right.
That's sort of the scope of with
Of
AI
course.
and medicine. There's a lot of ambition and hope for
That's,
this.
yeah.
As in to some degree an outsider from healthcare,
Yes.
but
Total answer.
someone who
Yeah.
knows what the power is like. Is there anything where you're like, that sounds like really inspiring, and or like it would you might have fear or concern about application, and just to seed that a little bit, um, the in fundamentally, like, the output is, let's say, non-deterministic from these models, and um, I think there's sort of a concern or potential that intervention from AI could be randomizing in a
Mhm.
way that's sort of unsafe, and things become uh, very impactful, and the stakes are very high, right? For small changes. For example, think about colon cancer screening. If a patient comes in and they report blood in their stool, right?
Yeah.
and you have, let's say, an AI scribe that now the doctor doesn't need to use the EMR, or they're hands-free. They're not looking at the fact that the EMR knows this
Mhm.
patient has a family history of colon cancer. But maybe the doctor's not looking at that because they're just hands-free with the scribe. And it sort of missed the fact that if you have, blood in the stool with family history of colon cancer is a different situation than someone with no family history of
Mm,
colon cancer.
mm,
And so these little changes,
mm,
right, in this case, this is actually a big change, which is like before doctors were looking at the histories and EMR, but then to sort of away from that, might miss this kind of thing, like introducing new risks with this type of technology. I just wonder if in projects you've worked on, or not
mm.
just with LLMs, but AI in general, machine learning in general, how you've thought about sort of the risks with these projects, or even just spitballing on like what you think should be on everyone's radar.
Well, that's a very big topic.
It's a very
Uh,
big topic.
I mean,
Yeah.
maybe I don't feel I have a very organized answer to
Yeah,
this.
yeah, yeah.
We will just like talk, whatever is on my mind,
Yeah, yeah.
under this general theme. I think first of all, in terms of like what I'm excited about, maybe AI advancement in the medical space, I think there are a lot. As you just mentioned, there's so many opportunity out there, right, for kind of the technology to help improve the performance of the systems. I'm definitely excited about the type of fancy things, right, like DeepMind is doing on AlphaFold,
Sure.
right,
Yeah.
or Python folder, right, being able to using
Deep
those kind
life
of
sciences stuff.
deep life science to invent new, medicine, cure cancer, extend
Yeah.
life, and for every human being, right? Those
Yeah.
kind of grand type of breakthrough and invention.
Yes.
I think now it all feels possible. It's on the horizon now. Okay,
Yeah.
and we're now talking about our generation can live to 120 to 130 years old, and it's not a fantasy. Like I'm prepared to live to 120 years. Okay, I tell my
Right.
team members that, hey, be prepared to work for until you're 80. Okay, so you have 50
Yeah.
more years to go. Don't ask for promotion every a year. You have 50 more years. We don't
Oh,
have that
that's
many
so good.
roles for you to be
It's a good
promoted.
management tactic. I like it.
Oh, seriously, like I am very excited about using AI and technology to help really making those uh, kind of medical breakthrough come true. Okay, and
Yeah.
it'll have such a profound transformation on humanity and on quality of life. Okay, so I think that's definitely a big category that I think we should all feel excited about. And then to your point about the middle tier,
Hmm.
um, I think there's so much to do. I feel really excited about the opportunity of using better technology and AI to, how do you call it, preventive,
Yeah.
like diagnosis.
Preventive. Yeah.
Like I would love to be able to have access to services that can just collect my data, like scan my, well, I don't know, scan my body or do kind of a whatever, take whatever samples you need, and then just like tell me what is the probability or likelihood that I
Yeah.
might, kind of get exposed to this kind of a disease or illness later
Yeah.
on. And
Okay.
what should I do? What should I eat? How should I change my life habits to reduce that exposure, right? Reduce
Yeah.
that. How can I live a more healthy
Have
life?
you done the scan? You can do the full body
I
MRI
heard
now.
there is now that thing.
Yeah.
I haven't personally done that, and it doesn't feel it's that accessible to every
Yeah.
person yet. But I'm
Yeah.
looking forward to the day when those kind of a technology, whether it's a hardware device, in advancement, and also kind of matched with algorithm, kind of improvement and innovation, all of
To
that.
like so you know what to do as a result. Right.
Right. So
Yeah.
I'm looking for the time when that type of a technology is readily available to every human being, and I can go to my annual physical check. I can actually go through that kind of a
Yeah.
uh, diagnosis, and then just have a full understanding about my health condition. Now it
Yeah.
feels like I go to this annual physical check, I got nothing. Okay, so it's like the doctor said, you're only like 38. We're not going to run this kind of an analysis on you. Like, you're not going to get a cancer pre-screening because you're not old enough. I just feel I get a very superficial, like shallow kind of insights.
Yeah.
I feel safe. No, seriously, I don't feel safe. I'm hoping that there is more kind of a comprehensive
Yeah,
uh, kind of a preventive type of diagnosis
yeah,
technology available to help give us more insights,
yep.
about what is our condition, health condition.
So in the sense of like assurance, right? That you have, um, and the examples are there. There's the full body scans, but there's other technologies. For instance, where having an accelerometer. This is a dumb watch, not a smart. This is my surfing watch. Um, its only real skill is that it's waterproof.
Yeah,
But for many people who have an accelerometer on their wrist,
yeah.
and the data from that accelerometer found, can predict Parkinson's, the
Hmm.
likelihood, or have a reasonably accurate estimation
Ah,
the likelihood
yeah.
of Parkinson's way better than
Yes.
alternative techniques, or
Yeah.
speaking cadence.
Right.
That analyzing changes in speaking cadence and other aspects of speech is correlated with mental health
Yeah.
status,
Yeah.
or typing speed on your phone. There's these like digital biomarkers
Totally.
that have like signals that we're not paying attention to. And so I'm hearing you say that, like, it's almost like it's just in a form that sort of signal processing has not been the provenance of medicine historically
Right.
and care delivery, but now with better tools we can make it. It's just like a thermometer or a blood pressure cuff
Totally.
or a scale or a reflex hammer, or
Yeah.
it's just another tool.
Yeah. I think all the pieces are there, right? We need to connect
Yeah,
them together, the hardware, the device, the software, the algorithms, and then
yeah,
we can potentially create a magic experience, magical services that can create a lot of value that was unimaginable before. Now it is actually all feasible to do.
yeah,
And I know this is already happening as we speak, right? There's some
yeah.
companies
People
that
working on it for
are
sure.
so
Yeah,
super excited about that. And then I know, like, on the administrative side, there's a lot of opportunity. Like, I go to my urgent care or sometimes go to hospital, schedule appointment. It's still a pain to go through that whole process. Um, I hope, like, for example, now, like, scheduling appointment with a doctor, it can take weeks for you to get onto the calendar, right?
yep.
I don't know. Like, I mean, I imagine there are opportunity for us to make that type of experience more
Quite
streamlined.
a bit easier for
And
sure.
then instead of also, like, you can work with a chatbot or a
Yep.
agent powered by AI to do
Yeah.
that.
And
That have
compress some of the back and forth, right? Because very often it's like, well, where do you go? Who accepts your insurance, right?
oh
Where
yeah,
and it turns out they don't, because the data is
yeah,
inaccurate, right? And so on and so forth. So no doubt the
yeah.
big
Maybe the
opportunities
last
there.
thing I would say that I'm excited about is maybe, is it called telemedicine? Like how do
Yeah,
you call it?
telehealth. Yeah,
They could be able to sit at home, open my computer or even mobile app, and then just be able to, I guess you can either speak to a real doctor or maybe just speak to AI, right? Like, you can speak to AI. The AI can basically look at you through the camera. Or maybe you can share information, talk about what you're
hmm
feeling, how you're feeling,
hmm
and you can get some real time, either diagnosis or advice, right? To address some um, maybe symptoms or conditions you're feeling.
questions
Um,
and concerns. Yep.
Question concerns, like, not going to fully replace the kind of the full-fledged, hospital service or doctor
Yeah.
service,
Yeah.
but
Yeah.
at least
But
I think
there's some
there's some
tier of
here.
need. Yeah.
Totally. I think this new kind of a wave of AI innovation will hopefully make those kind of medical service become more both like accessible, but also more trustworthy, reliable, right? And
Yeah.
higher quality. I think that's
Yeah.
also going to create a lot of benefits for all of us.
Yeah.
Um, I think you asked about did you ask about the risk, right? Or
Yeah,
concern?
well, I mean, like in this sort of utopian world where
Right.
I'm getting my scans, you're getting
Yeah,
your scans,
yeah,
and
yeah, yeah.
we're like always a step ahead. Whatever disease might be coming at us, we're always a step ahead. It's not going to eradicate disease until we get to all the proteins and gene therapies figured out, but like, we can at least have the best shot. Um, there's, there's plenty of examples already where it misses things, and there's, it changes. There's like the human machine interface where like throughout this process, it's not like an isolated, it's not that like AI doctor that you might talk to over
Right.
Zoom or telehealth is in a vacuum. It's also in a system that's
Mm.
helping pay for it,
Yeah.
right? That's helping insure
Yeah.
against adverse outcomes.
Yeah.
And people are gonna be looking at it. It's like it's like human machine interface creates it, an interesting
Mm.
sort of interplay where machines can aid humans. They can also create new vulnerabilities or new blind spots for them.
Mm.
Automation bias, the like.
Yeah.
Humans can supervise. We talk about like human in the loop, right? Is there a human in the loop? But
Yeah.
then what is the skill and what is the training and the practice? And so much of what makes experienced doctors more effective in terms of actual patient outcomes is just the repetition, 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 and exposure, 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 10,000 hours, right,
Yeah.
of this kind of thing. So, yeah,
Yeah.
we're
Yeah.
starting to unpack, I think, as a
Yeah.
very interdisciplinary group
Totally.
of what is the new
I
collection of challenges we have to solve.
I'm by no means a expert on this topic, but just some kind of a maybe like thoughts on top of my mind. So first of all, I
Yeah,
think
yeah,
we definitely need to do a good job protecting kind of a data privacy. Okay, I
yep,
think the medical information for every human, every person, that is a very, very sensitive and private information. So I do think we should take privacy very seriously. And as we're innovating, we need to make sure we create the right guardrails and also mechanisms, rely on the correct tools and then solutions, right, to ensure there
yep.
is a privacy. So that is the ground that I want to lay
That's
there.
like bare minimum floor.
Very, very important. Assuming we can do that well, the industry collectively can do that well, I really think um, we need to build a better bridge between the medical world and the tech world. You're trying to do that, right? So I think
Yeah,
I don't know what's the landscape now like today, but I imagine that there's a lot of silos. Okay, you know, each hospital or
for
each medical
sure.
system, they have their own set of data. Okay. And then there are walls between them and they're
Hmm.
not sharing data with
They have
each
their
other.
own set of algorithms,
They
also
have their
their
own
own
set of
data.
algorithm,
Oh,
data set, whatever. And then it's every like they have their own walled garden. They're
yep,
potentially planning to do something with that amount of data they have. But zooming out, look at the whole ecosystem, you can only create the most capable, useful, reliable technology if you can tap into all of that data.
for
Okay.
sure.
So we
Yep,
need to create a way for all of these different medical agencies to share those data in a safe manner without exposing, patient privacy, of course, and then allow the technologist to come in, work with these medical experts and medical
yep,
agencies to then create tools and systems and algorithms that can harness all the insights
yep.
that are
Buried in that data.
in the data. There's a huge amount of data, right?
Yeah,
And then
yeah,
I think that's how we can then create a truly powerful and a transformative technical systems and solutions, right?
yeah,
That can then benefit, uh, everybody,
yeah.
right? That can benefit.
The challenge, that's both the promise and the challenge, is the coordination is something that humans have done, and the collaboration, like interdisciplinary teams, and is something that has happened in industries and over again. But it's also one that kind of runs up against all the incumbent interests
Oh,
and a problem of the commons, right? Where it's like, well, I'm hospital system X, you're hospital system Y, and you have a standard and I have a standard. It's like, well, let's use my standard. Let's use yours. It's a third
oh,
party. Which third party, right? And it
I'm
becomes
not
these
saying
very
I
basic barriers.
totally. I'm not saying this is easily like doable. I think this is theoretically possible. I think it'll take tremendous amount of effort to actually make it happen. I imagine that the government probably should play a role. Okay,
It's yeah, it's trying.
you don't always want the government to be involved, but I think in this kind of situation, the government need to play a role potentially. And
Yeah,
then to your point, you need to create the right incentive structure to
yeah,
incentivize all the different entities in this whole value network to
yep,
want to participate and then be able to also benefit from the collective, the good outcome, That's
Yep.
like there need to be mechanism design to making sure there is the right incentives there.
Yeah.
You need some regulation or some whatever
Funny
policy
enough,
government.
you, the application of LLMs, even for at this level, like data transfer, right?
Yeah.
Like mind-boggling that fax is still a predominant method of data
Oh
transfer
wow.
in healthcare. And so like there are companies that are applying machine learning, deep learning to take fax and structure the data into a standard format that's more computable. And so yet another application of AI.
Yes.
Chen, it's we've run over. You've been super generous with your time. I'm glad we got a chance to catch up a little before this, but we'll put a pin in here and do this again in a year and see how far everything has come. And then I'll follow up and we'll get some time on the calendar for the families.
Fun conversation. Yeah.
Yeah, man. Thank you.
Beautiful.
I really appreciate it.
Yeah. All right. Later.
Talk soon.